Today we'll continue with the series on uniformly accelerated motion. In our previous class, I gave you the formulas required to solve questions under uniformly accelerated motion. So I'm going to look at some more questions on that. Let's take a look at the first question on the board. It says the motion of an object is shown in the figure above. Calculate the total distance covered by the object in 16 seconds. This clearly is a velocity time graph. Now for this type of velocity time graph, all I need to do is to calculate the area of the figure. The area of the figure gives the total distance we'll cover. I can start to split the figure into two parts, or we can just use what area of what a trapezium. There are two ways you can do this one. Let's split the figure, but there are some other questions you see that you may need to split the figure for you to get a proper understanding of what you want to do. So now, if we calculate the area, let's divide this figure into two. Let's call this one 1, and let's call this one 2. So now the area of the first one, that one is area of 1. Now that first part is a rectangle, and area of a rectangle is what length times what breadth. So I'll get 60 times 12, that was what 720. Now I get the area of the second figure. The second figure, there's a triangle. Area of the triangle, that's area of the second part. Area of triangle is half base times height. Half base times height. So I'll get half. The base is from here to this point, which is 16 minus what? 12. 16 minus 12. 16 minus 12. Then times the height from here to this part, that is what? 60. So this one will give us half times 4 times 60. 2 here, 1, 2 here give us 2, that will give us what? 120. So the area of the figure gives the total distance what covered. Therefore, distance covered that will now be 720 plus 120. That will give us 840 meters. 840 meters. So that's the distance what covered. So like I said, there's another way you can solve this particular question. You don't want to use this approach. You can use the area of that word figure. That's area of the trapezium formula, which is half, then the base plus that's from this point to this point, plus this one, times the height. Let's see that. Let's see that. Let me erase this one now. So if you don't want to use this approach, then we can have distance covered. Distance covered. That would be half. Then from this point to this point, that's 16. Plus, from here to this point, which is from here to here now, that is 12. Then times the height, which is what? 60. So this one will give us 2 years 1, 2 years what? 30. So we'll get 16 plus 12, that is what? 28. So we'll get 28 times what? 30. And that will give the same answer as what? 840 watt meters. So any approach you use, you arrive at just the same word answer. Okay? So it doesn't matter the method you use, but it's always better to understand both approaches so that if you get a question where you cannot use this particular formula, you can just split the figure so that you can now solve each of them separately. As we are going to see in some other questions we are going to be looking at today. Okay, let's see another example. If you have any question, don't forget to send it to me through the comment section, or you can send it to me through my WhatsApp number. which is plus 23480 368 55152. So let's see another question. Okay, so Air Force question 2 and Air Force jets. Air Force jets flying with speed of 335 meters per second went past an anti-aircraft. Anti-aircraft gun. How far is the aircraft? Five seconds later. 5 seconds later. Now for this particular question, so Air Force jets fly with speed of 335 meters per second. So what we have here is the speed. We're given the speed is 335. Then the time is what, 5 seconds. Now if you have a question like this, we're asked to get what the distance. The formula we use for this one is not the regular formula for uniformly accelerated motion, but we're reading was speed. And we know that speed is distance over time. Distance over time, speed is a scalar quantity. So speed is distance over time. So to get the distance, it means that speed times time will be equal to what distance. So what I need to do now is the speed times the time. The speed times the time, that will be 335 times what, 5. To multiply that will give us the distance. On 1,675. 1,675 meters. 1,675 meters. That is the value of the distance we have covered. So if I get a question like this, you're given the speed and the time to calculate the distance, you can use this formula. If you are given the distance and speed to calculate time, you can use the same formula. If you are given what the time and the distance to calculate speed, you can use the same word formula to get your what answer. It's a very simple question, okay? Let's see question 3. Question 3. Try as much as possible to give you a lot of questions on this topic so that when you see questions on this topic, you will be able to solve it with ease. Let's take a look at example 3. Example 3. A train has an initial velocity has an initial velocity of 44 meters per second and an acceleration of 4 meters per second squared. What is its velocity? What is its velocity after 10 seconds? What is the velocity after 10 seconds? So now if you want to obtain the velocity after 10 seconds, you need to get the parameters given in the question. Once you can obtain the parameters from the question, you will be able to easily dictate or identify the particular formula that contains all the needed parameters. Okay, let's see how we solve a question like that. The train has an initial velocity of about 44 meters per second. That's the initial velocity. Remember, initial velocity we represent it with u. That is 44 meters per second. Then an acceleration of 4 meters per second square. What is its velocity after 10 seconds? Now looking for v. So I'll think of the equation of motion to use. You cannot recall that, just quickly write all the equations of motion, equations of uniformly accelerated motion. Once you write down all the equations of uniformly accelerated motion, from there you quickly identify the one containing all the given parameters. So once you have been able to identify the one containing all the given parameters, you can now solve and get the needed answer. So let's say we have v equals u plus what? at. Remember, there are times we need to combine two of these formulas to get what the answer you need. So let's check first to see whether this one has the parameters I need. V, I'm looking for v. U is 44, A is 4, T is 10. So this one has all the parameters I need. Since this particular formula has all the parameters I need, then I can apply this one to get the final velocity. U is 44, acceleration is 4, the time is 10. So that will give us 44 plus 40, and that will give us 84 meters per second. 84 meters per second. So that is the value of the velocity. It's as simple as that. It's just for you to obtain all the parameters needed. Once you can obtain the parameters needed from the question, then you will be able to solve the question from any of the formulas that has all the needed parameters. As simple as that. Let's take a look at question 4. The body starts from rest and moves with uniform acceleration. Uniform acceleration of 6 meters per second square. 6 meters per second square. Full stop. what distance does it cover in the third second? What distance does it cover in the third second? Now, for a question like this, there's another way they can actually set this type of question for you. Let's see. Now, it said the distance covered in the third second. What it means is that the total time is what? 3. The total time is what? 3 seconds. So if you want to paraphrase the question like this, they'll tell you that the body starts from rest and moves with a uniform acceleration of 6 meters per second squared for 3 seconds. Calculate the distance covered in the last 1 second of its motion. If you see the question like that, it's the same thing as this one. Because the distance covered in the third second is the same as the distance covered in the last 1 second of the motion. Let me use a line to illustrate what I'm saying. You have a line like this. Let's say this is 0 points. So from here to here is 1. From here to here is 2. Then from here to here doing what? 3. The distance covered in the third second is from here to this part. This is the distance covered in the third second. The distance covered in the first second is from 0 to 1. The distance covered in the second is from 1 to 2. The distance covered in the third second is from this point to this point. Okay? So now that you know that, you see that it's saying that the distance covered in the last 1 second. Last 1 second, 3 minus 2 gives us 1. That's the last 1 second of the motion. So now let's find the parameters we have in question. The body starts from rest. That means u is equal to what? 0. And moves with uniform acceleration of 6 meters per second squared. What distance does it cover in the third second? The distance covered in the third second. Now, distance covered in the third second is going to be the total distance covered, that distance covered the entire 3 seconds, minus distance covered in 2 seconds. So distance we are looking for is distance covered in 3 seconds minus distance covered in 2 seconds. Distance covered in the first 2 seconds. Then we calculate distance covered in the 3 seconds, the entire time of 3 seconds. So the distance covered in 3 seconds minus distance covered in the first 2 seconds. That will give us the distance covered in the third second. So now that we know that u is 0, a is given, s is not given, we are looking for s. Remember, s is ut plus half at squared. U is 0, so that means this entire here, this ut gives what? 0. So that we'll get x becomes 0 plus half at squared. And that's something as half at squared. So now if I calculate distance covered in the first 3 seconds now. Distance covered in 3 seconds. That will be half. A is 6 times t. T will now be what? 3. That's 3 times 3. If we divide 2 as 1, 2 as 3. So that would be 3 times 3 times 3. That would be 7. Now distance covered in 3 seconds. Distance covered in 2 seconds. That would be half. A, then t is 2 times 2. This 2 we cancel this. So we have 6 times 2. That will give us 12. So the distance covered in the third second, which is what we are looking for, will now be 27 minus 12. 27 minus 12. And that will give us 15 meters. That will give 15 meters. It's just as simple as that. It's not something very difficult. Like I said, it's just your ability to quickly remember the formulas, which I said the best thing to do, write down all the formulas. This is about 4 I gave you 4 formulas. Write the 4 formulas, then bring out the parameters you have in the question. Once you bring out the parameters you have in the question, then check the formulas, look for the one that contains all the parameters. If you cannot find a single formula containing all the parameters, then you can combine 2 formulas to get whatever that it is you are asked to find in that particular question. Okay, let's see yet another example. Let's see example 5. Example 5. A particle starts from rest. A particle starts from rest and moves with a constant acceleration of 0.5 meter per second. First of all, what is the distance covered by the particle in 10 seconds? Distance covered by the particle in 10 seconds. Okay, for a question like this again, I will need to bring out all the parameters I need to solve the question. A particle starts from what? Rest. So I know I have what? U, the initial what? Velocity. I have the initial velocity U. U is 0, but the body starts from rest and moves with a constant acceleration of 0.15. Acceleration 0.5 meter per second. What is the distance covered by the particle in 10 seconds? T is 10 what seconds? We are looking forward to the distance. We are looking for the distance. So let's see. What is the best formula for me to use? First, we will have V equal to what? U plus what? AT. So I check. Can I use this formula to get the distance? No, I cannot use the formula to get the distance because I don't know. Okay, apart from the fact that V is not given, there is no S in this formula. So we have V squared equals U squared plus 2AS. Now we have distance, we have acceleration, this one is 0, but V is not given. So now I can use this, I can get the value of V from here, because U is 0, acceleration is given, and time is not given. I can get the value of V from here, then substitute into this formula to get the value of what? S. Then we have another formula, S equals U plus V all over 2 times what? C. So here the distance U 0, V is not given, time is what? Given. So I can also use this formula. So I can either use this one or this one, but that would be after I've obtained the value of what? V. So that means I need to get V first. So from there, I make use of this first formula to get what V. Remember I told you you can combine two formulas to get the answer to what the question. So V equals U plus AT. So V equals U0 plus A 0.5 times 10. So V will give us what? 5. So now that I've obtained the value of V, I can either use this one or this one, but I think I'll prefer this one. This one will be faster, so I won't waste my time doing square. Or maybe I'll do both of them so that you see you get the same answer. X equals U is 0, plus V, which is 5, all over 2 times T. T is what? 10. T is 10. So that will X equals 5 over 2 times 10. And that will give us 5 times 5. That will be 25 meters. For 2 years 1, 2 years 5. And that will give us what? 25 watt meters. 25 watt meters. Now suppose you decide to use the second formula after making your V as 5. Let's check this particular formula here. If we check that now, let's see if we arrive at the same answer. Now, we've obtained V as 5 there. So now let's get V squared equals U squared plus 2AS. V is 5 times 5 now. U is 0. 2 times A is 0.15 times what? X. So now this one will give us 25 equals this one is already 0, then 2 times that is 1s is something as s, so we get 25 divided by 1 equals s, which is the same thing as what? 25 watt meters. 25 watt meters. Okay? So that's the same answer with this one. So all the formulas, no matter the one you are using, if it has the parameters that you need, you can actually use it to solve questions in physics. Just for you to extract the given parameters from the question. Once you are able to extract the given parameters from the question, check all the formulas you have and identify the one that contains all the given word parameters. Once you are able to do that, that means you can actually solve the question by substituting the parameters in the given word formula. And then from there you obtain the answer to the question. If you find this video interesting and you have learned something from this video, ensure you subscribe to our YouTube channel. I'll see you in our next class.